algebra. We are in lesson 7 right now. I'm explaining steps for rewriting equations. So last lesson we talked about equivalent equations. Now we're really going to look at that just a little bit more. So what did we do to check to see if equations were equivalent? How do we know equations are equivalent? So now we're going to talk about like rewriting equations and how they're still equivalent. Okay? Moving me over. Always moving my head. Okay. A little bit. Oh my gosh. That's weird. Okay, there we go. Let's try this. So I'm not erasing anymore. I'm drawing. Okay, so today our learning goal is let's think about why some steps for rewriting equations are valid, but other steps are not. Algebra being like a whole bunch of stuff on one side of an equal sign, another set of stuff on the other side of the equal sign. This is like a balance. Whatever we do on one side of an equal sign, we have to do it on the other, or the balance gets out of balance. So let's talk about solutions. Okay, remember, a solution to an equation is something that you can plug into the equation and the equation is still true. The equation is still valid. So let's see if 0 is a solution to these equations. So if I substitute 0 in for x and I check my equation. 0 plus 2 is 2. That equals 8, which is not equal to 10. So this is a no, not a solution. Okay, let's try again. 12 minus 8, I'm substituting 0 for x. 3 times 0 plus 4. Right? So 12 minus 8. 8 times 0 is 0, so I've just got 12 on the left. And 0 plus 4 is 4 times 3 is 12. So 12 equals 12. Yes, that's a true statement. 0 is a solution to that equation. All right, here, if I plug in 0, if I substitute 0 for x, I get 5 times 0 plus 1/2, equals 1/2 times 0. Okay, what do we think about that one? 5 times 0 is 0. 1/2 times 0 is 0. Okay, does that look like it's a yes? Because that is a true statement. Okay, now 6 divided by 0 plus 1 equals 8. Okay, I cannot divide by 0. Okay, it's not allowed. I always tell my students that the world explodes when you try to divide by 0. So please do not be responsible for the world exploding. Okay, it's undefined is the fancy math word for it, but it's just not possible. We are not allowed to divide by 0 because it's just not a thing that you can do. Okay, all right, so let's move on. Explaining acceptable moves. I have another sheet of paper all set up to do this, but here are some pairs of equations. While one partner listens, the other partner should choose a pair of equations from column A. Explain why if x is a number that makes the first equation true, then it also makes the second equation true. So explain why if x is a number that makes the first equation true, then it also, so we're gonna pick x's. If x makes the first equation true, it also makes the second equation true. And then choose a pair of equations from column B. Explain why the second equation is no longer true for a value of x that makes the first equation true. So x will make the first equation true and not the second equation true, etc. Okay, so let's go ahead and do that. Got this set up. All right, so if we look at this, I can make this a little bit bigger. So if I look at the first equation, it's 16 equals 4 times 9 minus x. And then the second equation is 16 equals 36 minus 4x. I think if I distribute this through here, they're equivalent, right? Okay, so let's just say x equals 1. So I have 16 equals 4 times 9 minus 1. Okay, 16 equals 4 times 8. 16 does not equal 32. Did I misunderstand the instructions? Choose a pair of equations. Explain why. If x is a number that makes the first... I didn't understand the instructions. So let's rewind and try this again. Explain why if x... Oh my word. I thought I picked something better to help me erase. It's not better. Next time I'm going to push pause to erase because this is just embarrassing. All right, so if x is a solution to the first equation, and it's also going to be a solution to the second equation. So I'm basically going to say by the distributive property, that's the property we're using, by the distributive property, 4 times 9 minus x is the same as 36 minus 4x. So no matter what x equals, you're going to get the same solution for the first equation and the second equation. Okay? Now this one, okay, by the addition property, okay, so if those expressions are equal, let's get rid of this, if 9x equals 5x plus 4 is the same as 14x equals 4, okay, how did we get, so this right side of the equation, the 4's remain, but the left side has 14. I would have to add 5 to both sides of the equation to get 14 on the left. But then I have 10x on the right. Okay, so that doesn't work. What I really want is subtract 5x from both sides, and that gives me 4x equals 4. So 4x equals 4 and 9x equals 5x plus 4 are equivalent. Okay, those are valid moves and it works. All right, let's try the next one. So on the left, that's column A. We're trying to see why they're equal. And on the right, that's column B. So here, 5x equals 24 plus 2x. 3x equals 24. Okay, on that first equation, if I subtract 2x from both sides, I get 3x equals 24, which is the same as this one. Okay, so they're equivalent because, like I said, I have a balance here. If I subtract 2x from one side, I subtract it from the other side, and it's a move. Okay, this other one, my first equation is 1/2 x minus 8 equals 9. Now, if I multiply 2 here, it makes the 1/2, it cancels the 1/2 out. So I'm left with x. I also multiplied 2 here, and that gives me 18. What is wrong is I did not multiply 2 there. Okay, these would be equivalent. But the fact that I multiplied the ends by 2 but not the middle makes it wrong. A little bit better now? All right, so what did I do here? It looks like this is the same. The 3 is gone. The 3 is currently in the multiplication mode. So to do the opposite of multiplication, it's division. So it looks like I divided the left side of the equation and the right side of the equation by -3. So it's the whole thing. -3 cancels those out. I have to do it here too, -3. So that gives me 2x minus 9 equals -4, which is good because that's what I got. Okay, now here, 6x minus 6. To get from 6x minus 6 to x minus 1, it looks like I divided by 6, right? Okay, how could I show this better? I know if I divide by 6, I'm really dividing the pieces and the parts by 6 because that's subtraction in between them. So I'm left with x minus 1. I don't really like that way. I think that's harder to see. So let's see if I can do it a different way. All right, I got distracted. So I erased everything. Now I see that I can do the distributive property backwards and take a 6 out. Okay? Now, just like on the left-hand side, I can divide both sides by 6, which gives me the x minus 1, which is cool, but the second equation still has 3x, and it should be x over 2. Okay, that's another way to do it. The first way I did it, let's just review that really quick. I divided everything by 6. So that gives me x, that gives me 1, and we forgot this part, okay? X over 2. Cool, let's move on. Okay, why is this one correct? It looks like I just reordered these. So instead of 3 minus x, that x is, the negative is stuck with the x. So I have it -x plus 3. And that's cool. I'm allowed to do that. I didn't change anything with the math. Now, if I would have said x minus 3, that's not cool. I can't just willy-nilly change the order of things when they're subtracting. I can change the order of anything if I'm adding. Oh, sorry. But I cannot change the order of things just willy-nilly when I'm subtracting. That's not equal. All right, let's see what's going on here. It looks like this is the same, and this is the same, but I went from a -11 in a distributive property mode to a +11, okay? To undo the 11 or to move the 11, I can't add it because it's currently not being subtracted. You can do the opposite of what it's currently doing. So that's a really funny 11. So it's currently sitting there waiting to be multiplied. So to do the opposite of multiplication, I have to divide. And that gets rid of the 11. And that leaves me x minus 2 equals whatever -8/11 is. Okay? So they just added 11 to both sides. And if we would have added 11 to both sides, it would have looked like this. it would have been 11 being added to both sides. Okay? All right. Last one, I think. Okay, what are we doing here? It looks like I'm just collecting like terms. So 3x plus x is 4x, and everything else stayed the same. Cool. Here, it looks like I may have subtracted 4 from both sides, which is cool. I can do that. I can subtract 4 from both sides. But I'm left with a negative 5x equals 20. To get rid of that negative, I need to multiply everything by negative 1. So it would be 5x equals negative 20 if I want that negative to go away from the 5. All right, I think that's it. Yep, let's go back to the lesson. I hope you guys took really good notes on that because it's a lot of information. Cool. Okay, so next activity. Noah is having trouble solving 2 equations. In each case, he took steps that he thought were acceptable but ended up with statements that are clearly not true. Analyze Noah's work on each equation and the moves he made. Were they acceptable moves? Why do you think he ended up with a false equation? Discuss your observations with the group and be prepared to share your conclusions. If you get stuck, consider solving each equation. Okay, let's get that. All right, I needed more paper again, so we're back over here. All right, so we're analyzing what Noah did. We have our original equation. First, Noah applied the commutative property. And all the commutative, all the commutative property does is reorders. In this case, addition and subtraction. So we have negative 3 and we just reordered it. We put 4x minus 3x and moved the plus 1. We traded places. And as long as you keep the sign with the right term, perfect move. Then we combine like terms. So I have 4x minus 3x equals 1x. Cool. And then we subtracted x from both sides. Okay. Cool. So all of Noah's moves were perfectly acceptable. What this means is there is no valid solution to this equation. There is, and especially if I look at it right here, if I look right here, 6 or x plus 6 is equal to x plus 1. I have to plug the same value of x into the left and the right side. If I say, I don't know, x equals 5, well, 5 plus 6 is 11, 5 plus 1 is 6. It's not a valid statement. So there's no value for x that I can put into that equation to make it true, but all of his moves were perfectly acceptable. Let's look at the next one. Here, I have my original equation. Okay, we applied the distributive property by just distributing the 2 through that equation. 2 times 5 is 10, 2 times x is 2x. So that's perfectly valid. Everything is written the same. And then it looks like we subtracted 10 from both sides. Gets rid of that. And 9 minus 10 is negative 1. So I have 2x minus 1 equals 3x minus 1. Okay? Then I can add 1 to both sides. And that's also a valid move. And that cancels both of these out. So here I'm left with 2x equals 3x, and life is grand. Now the last move, I divide both sides by x. Yeah, I can't do that. All right, that's not a valid move. So I have 2x equals 3x. So I'm not allowed to divide both sides by x, okay? If I were to, say, subtract 2x from both sides, that's allowed. And on the left, I'm left with 0. And on the right, I'm left with x. So x equals 0 is a solution, right? It's the only solution. It's the only solution that works in that equation that is correct. Now, since we know x is 0 is the only solution, let's talk about this. If I divide both sides by x, and I know x is 0, I'm in a situation that I talked about earlier. I'm not allowed to divide by 0. Okay, it's not allowed in math forever. Not just in Algebra 1, but in Geometry, in Algebra 2, and any other math class. You're not allowed to divide by 0. It's undefined. It doesn't work. The world explodes. So I cannot divide both sides by x. All right? Yep, I think that's it. Oh, let's go back to our lesson. So I hope you have taken notes. Let's just talk about things. So we have the last few slides. Earlier, when looking at x plus 6 equals x plus 1, we reasoned that there's no value of x that could make this equation true. Is there a value of x that could make 2x equals 3x true? Yes, the only equation that, or the only value of x that works is x equals 0. If there is a value that can make 2x equals 3x true, what do we know about the original equation? Is it also true? What is its solution? Yes, like x equals 0 is a valid solution, and it would be a valid solution to the original equation too. Let's look at it. If I plug in 0 for the original equation, 2 times 5 plus 0 minus 1 equals 3 times 0 plus 9. Let's see. So here that equals 5. PEMDAS says I do what's in the parenthesis first. PEMDAS also says I do this multiplication first. 10 minus 1 is 9. Okay, that cancels out, so it's equal to 9. Okay, it works. So the equations are true up through the third step. The last step is where we have a false statement. After Noah shows division by x. If x is 0, what might the problem be with dividing by x? It's undefined. I'm not allowed to divide by x. I'm not allowed to divide by 0. All right, explaining steps for rewriting equations. Here, distribution property. Here, subtract 3 from both sides. Here, divide both sides by 5. And then here, let's see, what am I doing here? Divide both sides by x. Okay, that's not valid. Let me see what I'm supposed to be doing here. The move is made by dividing both sides by x. The second equation doesn't have a solution, even though the original does. So this I have a solution for. This one doesn't have a solution. There's no variables anymore. That move is problematic because it would eliminate the variable. Okay, we can't do this one. Cool. So A, B, and C, the second equation, I'm reading this bullet point, the second equation is the same as the first equation. And we've said why they changed. Distribution, we use subtraction, we use division, but D, that first equation is not equivalent to the second equation because it eliminates our variable. We don't want to eliminate your variable. So I can explain why some algebraic moves create equivalent equations, but some do not. I know how equivalent equations are related to the steps of solving equations. I know what it means for an equation to have no solutions and can recognize such an equation. Okay. I needed to delete that because I might use that for a quiz question later. And our glossary has not changed. Good job.